Hello, good afternoon. I'm going to present the unconventional reservoir analysis dashboard. The workflow starts with reviewing the well performance data. We have in this plot, we have the bottom hole flowing pressure and the oil rate. We need to look and make sure all the data are correct and we are not missing anything and the data makes sense. After that, we need to go to the next worksheet, and this worksheet actually this is just to understand when the early linear flow ends. You can see this vertical line on the left plot. It points to the end of the early linear flow, which comes from the fractures. Now you can see this is about 15, and we need to take the inverse square root of this number, which comes to 225 days. So for this well specifically, we need 225 days to till the end of the early linear flow. The right plot tells the it is a flowing material balance plot, and this one we can get some estimate of the stimulated reservoir volume oil in place, and for this specific well it is about 1700 m stock tank barrel. Moving to the next worksheet analysis, now we move to the evaluation of the stimulation job itself. We want to understand or get some kind of estimate of the fracture half length and the fractured zone or the stimulated zone permeability. So on the top left we have the linear flow analysis curve, which is the normalized pressure on the y-axis, and we have the material balance time on the x-axis. Drawing a straight line matching with the early data, we can get estimate for xf square root k. From the right plot, on the right plot at the bottom, we have the flowing material balance. It is the same plot as the one in the previous sheet. We get the estimate of the SRV, original oil in place. Combining these two results, the xf square root k, together with the oil in place for the stimulated reservoir volume, we can get estimate. If you look at the top, so in the middle you see this is the value for the xf square root time estimated from the first plot, and on the top to the left, after solving the two plots together, we can get estimate for the xf, which about 81 feet, and for the stimulated zone permeability it is 0.035 millidarcy. And actually, if we look at these numbers, this xf is we can say this is like the minimum we can estimate for this stimulation job, but there are assuming that all the stimulated or the fractures are connected together, there is no space between the fractures are left. The stimulation efficiency here is very high and everything is stimulated. But actually in reality, it could be you could have some fractures more effective, and there are some space between the fractures are not affected by the stimulation job, so we may expect longer xf than these numbers, and of course the value of the permeability will change accordingly. So moving to the next worksheet. So in this one, actually we need to plot all the wells. So if we select multiple wells here together and show them together at the same time, yes, something like that. So the shallow wells, or the shallow at the bottom, when you see the shallow slope, Usually this represents highly the stimulation efficiency is much higher, and this interprets for higher XF square root k numbers. For the wells going to the top, which the slope is very steep for these wells, this represents wells with lower XF square root k. So by comparing the performance of the wells together in this plot, we can decide which wells which wells have better stimulation than the others. So this is a very good one. We can compare results, and we can decide which way we can go in the next stimulation, how to optimize our stimulation. Can we go to the next type? Well, so here this one, I think most of the guys management and the operation guy like this one. So this represents the oil rate versus time, and you can see this dark the bold one passing through the middle. This is the type well. So this type well is the average of the rates of all these wells, and this, if you want to plan or you want to get some kind of estimate what will be the performance of a new well, how it will produce, this can give kind of guidance to you using this one. After doing so and getting this plot, we can think about forecasting, how we can forecast now and get the future production. So forecasting, in this dashboard we have two kinds of forecasting. We have the exponential decline and the harmonic decline forecasts, and as we can show here, this is both of in this well we have the early part, we have the historic data, and we have the harmonic forecast on the top, and the exponential decline at the bottom, and like this gives like the envelope or the range of expected forecast with time. So for this dashboard, I conclude now this is what this dashboard can help you in analyzing and forecasting your unconventional wells. And thank you for your time. Thanks.